we are moving on to the division property and zero property. I forgot to write the learning goal to this in topic. Topic is division property and zero, maybe division and zero property of exponents. And your learning target, I can simplify exponential expressions. We're going to start off with some prior knowledge. Recall that if I had x to the 1, 2, 3, 4, 5, 6, if I had x to the 7th over x to the 4th, you could expand it out like I have shown here. We expanded the x 7 times, and we expanded the x 4 times on the bottom, and then what did we do? Crossed them out. Many of you developed a pattern. We were left with x cubed. Now what's the pattern is now what we're going to actually apply. The pattern is called the division property of exponents, as long as they are the same base, okay? If we have a to the m over a to the n, it's equal to a to the m minus n, meaning just subtract the exponents. That's what that means. So as long as they're like bases though, because I can't do a to the 6 over b squared. You can't simplify that. You couldn't cross them out if you expanded it, okay? Examples, 4 to the 9th over 4 to the 5th. I'll expand it out at first. That's 4 times 4 times 4 times 4, 9 times. All over 5 4s. Cross out 1, 2, 3, 4, 5 of them. I'm left with 4 to the 4th. Now think to yourself, 9 minus 5 is equal to 4. If you ever get confused with the why is this true, why am I subtracting them, you can always go the expansion route. This would equal 6 to the 12 minus 5, which is equal to 6 to the 7. Now I'm just applying it. You do not have to show this middle step. Again, this is a unit where you do a lot of the work in your head. So you can jump from this first one right to the final answer. Okay? All right, the next one, x to the 13th over x to the 7 would be x to the 13 minus 7, which is x to the what? X to the 6. A to the 4th over a squared is a to the 4 minus 2, a squared. B to the 5th over b to the 4th is b to the 5 minus 4, which is just b. B to the 1st would just be b. All right, division property. We did it. We simplified division property with division expressions. Now we're going to advance it to coefficients. Oh no. It's a skeleton. What? The skeleton is not scared of coefficients. Okay. Notice what I do. Where is it going? What I do, I'll bring that down. What's 24 divided by 6? 4. So I write this as 4x to the 4 minus 3, 4x. Okay, that's what I do with that when it divides into a whole number, but sometimes it doesn't divide into a whole number. So I leave it like this and just kind of simplify it as that. And then I always do the subtraction on the numerator part. This would be 1x to the 5 minus 1 all over 3, which is just x to the 4 over 3. Because 1 times x to the 4th would just be x to the 4th. That's why I leave it like that. So when you do that subtraction, you do the subtraction, just put it back on the numerator, okay? Another example, if I had 2x to the 8th over 5, now let me do 1 is divisible by, let's do 18x to the 5th. I would simplify 1/9, and then I'd say it's 1x to the 8 minus 5 all over 9. X cubed over 9. That's how I would handle that. Okay, so we did division property with no coefficients, bumped it up to division property with coefficients. We got more to do. Now we're going to do zero property. The zero property of exponents states that anything to the 0 power is 1. Okay? Anything to the 0 power is 1. Now think logically about this. 12 to the 1st over 12 to the 1st would be 12 to the 1 minus 1, 12 to the 0, 1. Okay? When you look at it, 12 over 12, you already know it's 1. It's that same reasoning. Okay? All right, so check my technique out here. Well, here, x to the 4th over x to the 4th would be x to the 4 minus 4, x to the 0, 1. Okay? You should be able to identify that would be 1 anyway, seeing that they're right on, they're the same thing on the top and bottom. Notice how I do this one. This would be x to the 6 minus 3, y to the 8 minus 8, x cubed, y to the 0. What I always tell my students, when you have y, anything to the 0, you just kind of cross it out because it's 1. 1 times anything is that other number itself. So my final answer would just be x cubed. It's really x cubed times 1, but that is just x cubed. Okay. All right, advancing it more. 3 to the 4th, x cubed, y to the 15th, over 3 squared, x cubed, y to the 5th. 3 has the same base, so I can subtract the exponents. This would be 3 to the 4 minus 2, x to the 3 minus 3, y to the 15 minus 5. 3 squared, x to the 0, y to the 10th. Again, my strategy, anything to the 0 power is 1, so I just kind of get rid of it. This is just 3 squared, y to the 10th, which is 9y to the 10th. A lot of properties. Nope. All right, we are extending our exponent property knowledge. An expression, a simplified expression, should never, ever, 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 ever have a negative exponent. It is not simplified if there's a negative exponent. For example, 3 to the negative 2, you don't see that often. It is not simplified. A simplified expression always has positive exponents. Okay? So, we need to, if it's negative, we need to figure out a way to turn it positive. So to turn it into a positive exponent, what we do is put the exponent to the opposite part of the fraction. Because every number can be written as a fraction, okay? Even whole numbers, 4 is really 4 over 1. So, let me show you some examples and you develop this property yourself. I'm going to just tell you some facts. 2 to the negative 2 is equal to 1/4. It just is. 3 to the negative 2 is equal to 1/9. Try to formulate the pattern. 5 to the negative 2 is 1/25. 2 to the negative 4 is equal to 1 over 16. Okay, 3 to the negative 3 would be 1 over 27. Can you see what I did?
Yes.
Okay, now let's apply it. It's called the negative exponent property. Okay, just write the negative exponent property states that to turn it into a positive, a simplified exponent, you just move it. Okay? Notice that x squared was kind of on the top. It was x squared over x to the negative 2 over 1. We put it on the bottom, turned it positive. X to the negative 2 down here, 1 over x to the negative 2, is on the bottom. We put it to the top, it turns it positive. If you want to change the sign, you change the location. The how. How does this happen? It's one of those things that I just accepted. I plugged them into my calculator. That's how I got to know those facts of 2 to the negative 2 is at 1/4. It's one of those things that I just accepted. Okay? I just accepted it. I don't try not to overanalyze it and try to just apply it. So now that we learned it, I'm going to reevaluate and simplify these exponent expressions. Okay? X to the negative 4th would turn into 1 over x to the 4th. Because x to the negative 4 is really on the top, the numerator. To turn it positive, I change that location. If I change the sign, I change where it's at. 4 to the negative 2, again, it's 4 to the negative 2 over 1. What I'm really going to do is scoot that to the bottom. And then it turns into 1 over 4 squared. This, the only thing that has a negative exponent is the a to the negative 5. The only thing I'm going to move is a to the negative 5. B squared is already simplified. This would be b squared over a to the 5th. Which brings us to our next slide. Steps for simplifying a negative when there's more than one term or more than one part. The first thing you're going to do is box off the terms that have a negative exponent. Box it up. And then move it. Box off, move it. Okay, x cubed, it's the only thing there. So it would be 1 over x to the 3. Once I move it, it turns it positive. A squared, b to the negative 3. Which one has the negative exponent? B does. Box off the b. That's the only thing moving. So I'm going to put that on the bottom. It turns into a squared over b cubed. X to the negative 4, y to the 4. What has a negative exponent? Box off the x, move it. I have nowhere to go, so I make it go to the basement. That's simplified. You always know that you're simplified if the exponents are positive. Yep. Okay, so keep in mind, we just dealt with the division property today so far, which is when we subtract the exponents. Okay, a to the b over a to the c is a to the b minus c. We dealt with the zero property. Anything to the 0 power is 1. Okay, we now dealt with negatives. The negative property states that if you're negative, move it to turn it positive. That's the gist of it. All right, I'm going to show you multi-step examples here. This one would turn into 2x to the 4 minus 3, y to the 5 minus 7, all over 3, which is 2x, y to the negative 2 over 3. Move my negative exponent down. 2x over 3y squared is the final simplified expression. The next one would be 4a to the 3 minus 6, b to the 5 minus 1